All right, good morning, welcome back. Advent of Code, day 9. Let's get it done. Let's see. With your neighbor happily enjoying their video game, you turn your attention to an open data port on the little screen in the seat in front of you. Though the port is non-standard, you manage to connect it to your computer through the clever use of several paper clips. Upon connection, the port outputs a series of numbers, which is your puzzle input. The data appears to be encrypted with the exchange masking addition system, which conveniently for you is an old cipher with an important weakness. Xmas starts by transmitting a preamble of 25 numbers.2 of each number you receive should be the sum of any two of the 25 immediately previous numbers. The two numbers will have different values, and there might be more than one such pair. For example, suppose your preamble consists of the numbers 1 through 25 in a random order. To be valid, the next number must be the sum of two of those numbers. 26 would be a valid next number, as it could be 1 plus 25, or many other pairs, like 2 and 24. 49 would be a valid next number, as it's the sum of 24 and 25. 100 would not be valid. No two of the previous 25 numbers sum to 100. 50 would also not be valid. Although 25 appears in the previous 25 numbers, the two numbers in the pair must be different. Okay. Suppose the 26th number is 45, and the first number, no longer an option as it is more than 25 numbers ago, was 20. Wait, suppose the 26th number is 45, and the first number, no longer an option as it is more than 25 numbers ago, was 20. Now, for the next number to be valid, there needs to be some pair of numbers among 1 through 19, 21 through 25, or 45 that add up to it. Okay, so preamble means that there's 25 numbers, and those 25 numbers have no requirements. They're just 25 numbers. It should be sum of any two of the 25 immediately previous. Okay. Suppose the 26th number is 45. Okay. And the first number, sorry. Oh, I see what this is trying to say. It's saying because 20 is now excluded, I can only use 1 through 19 and 21 through 25 in this example. And then 45. 26 would still be a valid number. 65 would not be valid as no two of the available numbers sum to it. 64 and 66 would both be valid as they are the result of 19 plus 45 and 21 plus 45. Here's a larger example which only considers the previous 5 numbers and has a preamble of 5. Okay. In this example, after the 5-number preamble, almost every number is the sum of two of the previous 5 numbers. The only number that does not follow this rule is 127. So 127 is the only one that's an invalid input. The first step of attacking the weakness in the Xmas data is to find the first number in the list after the preamble, which is not the sum of two of the 25 numbers before it. What is the first number that does not have this property? Okay, that's pretty easy. Okay, what we're going to do, no regex today, a little sad. I was looking forward to practicing that and mentally prepared, but it's okay. Lines is going to be input dot split on the oh my gosh, I cannot type this morning. Split on the new line character, and then map these two integers. And because these are substrings, we do this. Okay. Did that work? Anonymous. I can do that. There. Request received. Done. Okay, so that gives us the numbers. And then we're going to say for I in 5 through lines.count. Is that right? Yeah, and then we're going to look backwards. Okay. And then we are going to say for j in I minus 5 through I. I think that's right. So it starts at 5, which means this loop would go from 0 through 4. Perfect. And then for k in j plus 1 through j through I minus 5 still, I think. No, through I. Okay. This is the same as like day 1. Yeah, day 1. This is the same thing. I'm just like trying to be smart first time around about this. Okay. So let number to match is equal to lines sub I. So that's the number we're trying to match, which would be 0, 1, 2, 3, 4, 5. So we're trying to match 40. And then we're going to look at every combination of the previous. So we're going to say let first possible equals lines sub j, and let second possible equals lines sub k. And then we're going to say if first possible plus second possible equals number to match, then we are going to break. Is this, oh, is this, no. We want integers, not optional integers. Perfect. We're going to break, and here we are going to use the handy dandy labeled break that Lance Parker taught us about. Go follow Lance on Twitter. He's been teaching me stuff this whole time. Okay, so this is kind of like a little self-contained thing, right? Search, if we find one that matches it, bail out. And then we're going to say var found match equals false, found match equals true. So then at the very end here we can say if found match equals false, and we continue. Else, if we did not find a match, we are going to print number to match, and we're going to break out completely. Okay, so let's run this on our input. Let's see if it crashes. And more importantly, see if we did it right and gives us a number. So it says 127. The only number that does not follow this rule is 127. Okay, we're going to do this really quick. We're going to say let preamble size equals 5. Preamble size, anywhere else that we wrote 5. Okay, perfect. Okay, so now what we want to do is we want to take the real puzzle input I want to do the same thing, but the preamble size is 25 if I'm not mistaken. 1 through 25. Okay. Build failed. Did I do something wrong with my... Oh gosh, they get real big, don't they? Okay, that's what it says the answer is. Happened pretty fast. We'll see. That was okay, cool. The final step in breaking the Xmas encryption relies on the invalid number you just found. You must find a contiguous set of at least 2 numbers in your list which sum to the invalid number from step 1. Again, consider the example in this list, adding up all of the numbers from 15 through 40 produces the invalid number from step 1. Of course, the contiguous set of numbers in your actual list might be much longer. To find the encryption weakness, add together the smallest and largest number in this contiguous range. In this example, there are 15 and 47 producing 62. Okay, let's switch back to this simpler input. Okay, so we're going to say var bad number equals 0 to start with, but we know we will find one. Bad number equals bad number, print bad number. Okay, so now what we're going to do, we're going to search again. We're going to search bad number equals, what was it? It's a line number to match. Number to match. Okay, so now in part 2, we're going to go through, we're going to, for I in 0 ... less than lines.count, we're going to go, we actually need 2, so let's do 1, and then we're going to do for j in I minus 1 ... less than lines.count. Is that right? I want those flipped. Yeah, I want those flipped. 0 I plus 1 lines.count minus 1. Okay. Okay, so what we're going to do, we're going to go through, we're going to start here, and we're going to say, actually, no, I actually want the full thing. So we're going to start at 35, and we're going to keep summing until we get the bad number or go over it. So current total equals 0. So we're going to say current total plus equals line sub j lines. So we're starting on 35, and we're just going to add all of them up. If current total equals bad number, we're going to save it and break. Else if current total is greater than bad number, we're also going to break. So this break will just stop us from cruising along and adding stuff. And it'll just start the loop over. Well, this is, we're going to say var, let's say range start equals 0, var range end equals 0. So what we're going to say is range, okay, so we can just do range start equals I, range end equals j, and then we're going to break to the outer labeled loop, which is cool. Again, thanks, Lance. Okay, and then we're going to say print range start, range end. Okay. Oh, gotta change preamble size back to 5 in our example here. Okay, 2 and 5, and it says 0, 1, 2, 3, 4, 5. Perfect. And so then what we're supposed to do, what is the to find the encryption weakness, add together the smallest and largest number in this range. In this example, these are 15 and 47. Okay, so then we're gonna say, I'm gonna keep printing just because I like seeing it. I in range start through range end, because those are actually the indexes. We're going to do all of them. Var min equals 0, var max equals 0. Okay. Oh, no, that won't work. Yup. Can I do, is there an end? I'm assuming there's an end up in. Cool. Okay, so then what we want to do is we're going to say if lines, let's see, let number equals lines sub I. We're going to grab the number, and if it's the smallest number we've seen so far, it's the min. If it's the largest, it's the max. So if number is less than min, min equals number. If the number is greater than max, then max is equal to the number. And then we're going to print out min, max, min, plus max. Okay. So 62 is the result, producing 62. All right, let's switch back to our puzzle input, and let's not forget to change our preamble to 25. And we'll also verify that our build failed, probably because I screwed up the line at the end again. Yeah. Let's make sure that we get matching answer. Puzzle answer was 1, 1, 2, 4, 3, 6. Yeah. Okay, so I didn't script the preamble, and that is that's the answer. That big old number. Done. Okay. Day 9. So let's talk really quick. So learnings, first of all, this is the first chance I've had to put in these labeled breaks, which is awesome. So basically how this feature works, if you weren't following along, is you can call break with the label and it'll jump you to that point, rather than like if you just call this break, it just picks the next loop that you're in and goes to there. So that's cool, something to learn. In terms of the algorithm, so for those of you that aren't familiar with doing these kind of array searches, basically what you're trying to do is you're trying to line it up so that, let's pull up an input here, so that if I'm searching here, I needed to look at multiple numbers in advance. So in this case, the preamble started me 0, 1, 2, 3, 4, 5. Start me here. Start me here. Okay, so this is where I started. Okay. Now, because the preamble size was 5 in the example. So it starts at index 5, which is right there. Okay, then what we're doing though is we are searching for the two numbers. So that means that if we were searching for one number, we could just use the one loop 4j in I minus preamble size. Did I do that wrong? Hold on, let me think about this for a second. I in preamble size, I minus preamble size. Oh, no, I'm searching the preamble, sorry. I'm getting the two parts of the problem mixed up. So this is where I have to end. And so these are the numbers I'm searching. So if I was just searching for one number that matched a criteria, I could just use this loop, and J would point here, and then 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 we'd be done. But we're trying to look at two numbers. So this is why we've got this J plus 1, and I maybe should do I minus 1, but it's fine. It's working. So what this makes it do is we have J and J plus 1. So that means we look at this number and this number. Now, once we are in this loop, that's when we're marching the second number along. So we're looking at this number and then this number, and then this number matched with this number, and then this number matched with this number. And then if we get all the way through those 5 numbers, which would be I from this very beginning, which was the preamble size, right? I starts there. If we get all the way to the end, then J would step forward 1, but K would also step forward. So K would actually be 15 and J would be 20. So that's how these kind of loops work. You're marching 2 numbers along. And I think it said you can't use the same number twice or something. I didn't put forth any effort to not try to use the same number twice, and it didn't bite me. Maybe I should have cared more. Because I can also, in this case, J should probably be I minus 1, since K goes all the way to I. In fact, like, I'm a little curious if I run it, do I still get the exact same 11 to the yeah? So I get the same answer, but that's probably the more technically correct way to do it, because I'm guessing what ends up happening here actually is you would end up with J plus 1, which is I, and so this loop would do nothing. So this saves us some checking. It's not a huge difference. Okay. Hopefully you learned something there, and hopefully you've seen enough of these IJK style loops that you're starting to like understand this pattern of like, this is how we search through steps in an array. Maybe what I'll do tonight is I'll make a little extension on an array that searches 2 deep, 3 deep, whatever. Maybe there's a way I can generalize this solution and make it more applicable. All right, if you like these videos, like and subscribe, helps us grow. Share it with other people that might be interested. Also, come back tomorrow. We're going to be solving another advent of code. Look forward to seeing you. Bye.